Bismillahirrahmanirrahim. Assalamualaikum. Welcome to my YouTube channel Diversity of Plants Zone. Today my topic of video is evidences of anatomy, cytology and chemistry in relation to plant taxonomy. I hope you will like my video and appreciate my work as well. So let's start the video. First of all, I will define plant taxonomy. Plant taxonomy is the branch of science which deals with the identification, nomenclature, and classification of plants. It means plant taxonomy has three different aspects. First is identification, second is nomenclature, and third is classification. Anatomy in relation to plant taxonomy. First is vegetative anatomy. Vegetative anatomy includes parts of the plant body that serve to maintain its individual life. For example, leaf, root, and stem are included in it. Second is floral anatomy. Floral anatomy includes the essential parts of the flower, which are means for the reproduction. Vegetative anatomy in relation to taxonomy includes epidermis, stomata, trichomes, stem anatomy, nodal anatomy, leaf anatomy, stadiates, specialized cell and cell content, and wood anatomy. First of all, I will discuss about the epidermis. Epidermis includes the shape, wall thickness, wall sculpturing, and inclusions in the epidermal cells. Papillate epidermal cells in the gramineae. Presence and distribution of silica bodies in the Cyperaceae. Sclarification of the wall of epidermal cells in the some genera of the Compositae. Presence of very narrow epidermal cells in the Stylidaceae. Different types of epidermal cells in plants as shown in the figure. Second is stomata. Morphology and development of different stomatal types is important in assigning the taxa of uncertain affinities to proper position. Morphology and ontogeny, number and arrangement of subsidiary cells and their relationship with other epidermal cells are characters of the taxonomic significance. Significance of stomata has been confirmed in the taxonomy of gramineae, Apocridaceae, Combretaceae, Rubiaceae, Acanthaceae, Umbelliferae or Umbelliferae, Papilionaceae, Ariliaceae, Myrtaceae, and Cyperaceae. Different types of the stomata are there as shown in the figure. Trichomes. Trichome types and their distribution are useful characters in distinguishing various genera of the Fabaceae. Position by the Nectanthes in Olaceae has been confirmed by the Namdar 1967 on the basis of structure and ontogeny of trichomes. Trichomes have been the main basis of the formation of generici for the members of the Compositae. Trichomes, there are different types of the trichomes as shown in the figure. Stem anatomy. Stacey, 1970, has shown that the anatomy of the stem can be used to distinguish the majority of its British species. For example, Dioscorea species are distinguished on the basis of the stem anatomy. The transformation of cortex into transparent tissue in the Casuarina. Structure of stem endodermis in the families such as the Asteraceae and Preparaceae. Presence of bilateral vascular bundles in two alternate rings of the Cucurbitaceae. Occurrence of cortical and medullary bundles in some families such as Amaranthaceae, Chenopodiaceae, and Nectaginaceae are some of the features of taxonomic importance. Internal structure of the stem of monocot and dicot. First of all, I will discuss the internal structure of dicots. Dicots include the xylem, as shown in figure. Second is phloem, sclerenchyma. Sclerenchyma is also called fiber cells. Epidermis, vascular bundles, cortex, pith, and ray of the ground tissue connecting the pith to the cortex. This is the ray of the ground tissue which is connecting the pith to the cortex. On the other hand, monocot internal structure of the stem includes this is ground tissue, this is epidermis, and these are the vascular bundles as shown in the figure. Fifth is nodal anatomy. According to the Taxon 1975, correlations of nodal anatomy with some other features might help significantly in tracing the phylogeny of angiosperms. Philipson 1968 attempted to use nodal anatomy as an aid to taxonomy. Sennett 1914 considered the trilacunar knot as the primitive and unilacular and multilacunar knots as advanced. According to the Paliwal and Anand 1978, majority of the cotyledons, dicotyledons possesses the trilacunar knots. Unilacunar knots are found in the laurels, Caryophyllales, Auricales, Abomeales, Primulales or Primulales, Myrtales or Myrtales, and a few Astridae members. Multilacular knots are found inside the Magnoliales, Piperales or Piperales, Trocodendrales, Umbellales or Umbellales, Astrales. Different types of the knots in plants as shown in the figure. Next is petiole anatomy. Metcalfe and Chalk 1950 and Howard 1963. According to the Howard, families, genera, and even species may be identified by the petiole characters, such as its position on the stem, presence and absence of the stipules, its vascularization, nodal structure, number of the traces, etc. Petiole anatomy of the 64 species of the Bufia of Leguminosae or Leguminosae. Some species of the Phlomes and Aremo stitches of Labiate provide the clear-cut support of the use of petiole anatomy in taxonomy of these genera. Petiole anatomy as shown in the figure. Next is leaf anatomy. Koyama 1967 studied the leaf anatomy of several species of Cyperaceae and formulated keys to identify the various species of Cyperus and Phryna, etc. Leaf anatomy has been widely used in several taxonomically different groups such as the Euphorbiaceae, Cyperaceae, Gramineae of angiosperms, and Coniferae of gymnosperms. Patterns of distribution of sclerenchyma in Corex and Fistuca have been used in distinguishing the species. Sclerenchyma is also used in differentiating two genera of the Valoziaceae, Valozia and Barbexinia. Leaf anatomy as shown in the figure. Leaf anatomy includes cuticle, collenchyma cells, guard cells, xylem and phloem, stoma, vein. This is also cuticle, This is upper epidermis. This is palisade parenchyma cells. This is spongy parenchyma. On the other hand, this is lower epidermis. Guard cells. These are the guard cells as shown in the figure B. This is epidermis cell and this is stoma. In the third figure you can see this is vein. These are the air spaces and these are the guard cells as shown in the figure. Next is scleriates. Scleriates are the cells with very thick lignified walls. They are extremely rare in monocots except in certain genera of the Oraceae and Agawaceae, Ericaceae, and a few other families. In dicots, they are more common in woody form than in the herbaceous ones. Next is specialized cells and the cell content. Microscopic characters of the cell content, such as the starch grains, for example, in the Solanum tuberosum. Protein bodies, like found in some members of the Cactaceae. Albuminoids, found inside the Lapotia. Large silica bodies, which are usually present in the Musaceae, Ericaceae, and Zingiberaceae. Calcium oxalate crystals, which are usually found in the Echornia and Ilium. Cystolates, which are usually present in the Moraceae and Urticaceae. Tanniniferous cells. Tanniniferous cells are usually found inside the Xeridaceae. Are important diagnostic tools and at times proved extremely helpful in delineating species, genera, and families. Next is wood anatomy. Some important wood elements of taxonomic importance are vessel elements, vascular rails, axial parenchyma, presence and absence of the storied wood, presence and absence of lattice vessels, resins, gums, and crystals, etc. Wood anatomy has prompted the allocation of the Amborella, Tetracentron, and Trocodendron to their respective independent families. Placement of Myristicata close to the Lauraceae. Delimitation of different subgenera of the Quercus, of Fagaceae, and the non-inclusion of the Calicanthaceae in Rosales or Myrtles are all supported by the wood anatomy. Internal structure of the wood as shown in the figure, which includes bark, bast. Bast is the inner bark. This is cambium and medullary rays. This is sapwood. This is heartwood, and these are the growth rings. Next is floral anatomy. Floral anatomy of the Ananaceae. Calicanthaceae, Menispermaceae confirm that all these families are originated from the Ranunculaceae. Uniformity in floral vasculature of Solanaceae and Scrophulariaceae suggests that both should be included in the one single order, which is Scrophulariales. Separation of the Peonia from the Ranunculaceae and its inclusion under a separate family of the Peoniaceae was supported by the floral anatomical studies. Formerly, Cyperaceae and Gramineae were treated together in the one single order, but Hutchinson, 1973, treated them separately in the Cyperales and Gramineals because of their floral anatomy. Lilia, earlier included under the family which is called Characterize, was later separated in an independent family of Liliaceae. Internal structure of the flower is shown in the figure. Internal structure of the mature flower includes the stigma. This is style. This is filament. And this is perianth. Perianth includes petal, chlora, sepal, and calyx. This is nectary. This is the floral axis. This is articulation. This is pedicel. On the other hand, the stamen. Stamen includes the connective, and this is called the anther. Anther includes the microsporangium inside it. On the other hand, ovary. This is the ovary region, and ovary includes ovule inside it. Cytology in relation to the taxonomy. The term karyotype is used for the phenotypic appearance of the somatic chromosomes. The diagrammatic representation of the karyotype is termed as ideogram. The characteristics of chromosomes which have proved to be taxonomic value include chromosome number, chromosome size, chromosome morphology, chromosome behavior during the meiosis. First of all, chromosome number. Chromosome number includes 4 types. First is homoploids. Homoploids exhibiting similar degrees of ploiding. Examples are Pinus and Quercus. N is equal to 12. N stands for the number of the chromosomes. N is equal to 12 means there are 12 chromosomes. Second is polyploids. Polyploidy is the heritable condition of possessing the more than 2 complete sets of chromosomes. And different species of aster have N is equal to 9. And N is equal to 18 or N is equal to 27. On the other hand, euploidy. Euploidy is a chromosomal variation that involves the entire set of the chromosome in cell or in an organism. Last is aneuploidy. Aneuploidy is defined as any deviation from the normal number of chromosomes, usually meaning a cell nucleus and possessing too many or too few chromosomes. For example, the different species of Brassica bear number of the chromosome N is equal to 6, 7, 8, 9 or 10. Chromosome size. Chromosome size usually ranges from 0.5 to 3 mu. According to the Stebbins 1938, the chromosome size is characteristics of only certain groups and families and not related to the phylogeny of the angiosperms. Chromosome morphology. Relative length of the arms of the chromosome, position of the centromere and presence of the satellites, etc. are some character of taxonomic significance. A secondary contraction may be present near the terminal end of a chromosome, separating its small segments and called satellite or SCT. Chromosome may be symmetrical and asymmetrical. Chromosome morphology is shown in the figure. First of all, there is metacentric chromosome, which includes the centromere, and this is the primary contraction. These are the arms of the chromosome. Second is submetacentric chromosome, which includes the 2 small chromatids, and this is the short arm. This is long arm. Third is acrocentric. Acrocentric chromosome includes the satellite or SAT, and this is the telocentric chromosome. Chromosome behavior at the meiosis. Degree of the sterility and occurrence of hybridization are determined by the behavior of chromosome during the meiosis. Abnormalities in meiosis such as the non-pairing, crossing over, unequal interchanges or translocations bridge formation, lagging chromosome, etc., have all proved to be the systematic value. Next is systematic value of the cytological studies. Jackson, 1971. Members of the Cyperaceae. Members of the Cyperaceae and Jancaceae possesses chromosomes with diffuse and non-nucleized centromere and also show the inverted meiosis. This reflects a close association between these two families. Yucca had long been treated as a member of Liliaceae because of superior ovary and a gave of the Amaryllidaceae because of the inferior ovary. Hutchinson shifted both the plants to Agawaceae because of the presence of 25 small and 5 large chromosomes in both of them. The basic chromosome number in the Laurentiaceae is n is equal to 9, while in the Viscaceae there is a series of aneuploidy numbers ranging between 10 to 14. Wins, 1975, separated them from each other on the basis of the cytological evidences. In the subfamily of the Bambosoideae of the Gramineae, n is equal to 12, and in the subfamily of the Poideae or Poidea, n is equal to 7. This indicates that the chromosome number have proved to be the taxonomic utility also at the subfamily level. Stebbins, 1958, provided information on the evolution of grasses on the basis of the cytogenetic studies. On the basis of cytological studies, Lewis, 1951, submerged the genus Cordicea in Clachia. Onagraceae. Neck, 1977, differentiated the 3 species of chlorophytum of Liliaceae in the basis of the cytological data. Warburg, 1938, studied the taxonomy of the Garnials on the basis of cytological studies. Manton, 1932, confirmed formation of subdivision of Brassicaceae on the basis of the cytological studies. All the families have different base chromosome numbers. Genus Cistus or Cistaceae, formerly included in the Helianthemum, has chromosome number 8, while the Helianthemum has the base chromosome number 9, so the Cistus should be recognized as a separate genus. A new classification of genus Narcissus of the Amaryllidaceae has been proposed by the Fernandez in 1951 on the basis of the cytological studies. Sharma, 1956, on the basis of his studies of Ericaceae, Amaryllidaceae, and Dioscoriaceae, proposed that changes in the karyotypes of somatic tissue play a distinct role in the evolution. He further proposed that the large chromosomes, low chromosome number, and symmetrical karyotype represent a primitive status, while the small chromosomes, high chromosome number, and extreme asymmetry of the karyotype represent the advanced status. These principles provided interesting results in taxonomy of the Alismataceae, Liliaceae, and Amaryllidaceae, and Dioscoriaceae. Chemistry in relation to taxonomy. Application of chemistry to taxonomy is called the chemotaxonomy. Chemical evidences are used in determining relationship among taxa of different categories. Some of the major classes of the chemical evidence include the flavonoids, alkaloids, amino acids, fatty acids, aromatic compounds, terpenoids, polysaccharides, and carotenoids, etc. Chemistry in relation to taxonomy. Cronquist, 1981, cited following examples to indicate the use of chemistry in solving the taxonomic problems. First, Caryophyllines produce the betalains and not the anthocyanins. Polygonales produce the anthocyanins and not the betalains. Jugulentales are the aromatic plants, while the phagales are non-aromatic. Highly aromatic compounds are found in the Lamiaceae. Alkaloids are very common in the Solanaceae, and Sabindiaceae have plenty of the tannins. If you like my video, please like and subscribe to my channel. Thanks for watching. Thank you so much.